So this next question, I've already started it. I need to define and show that the derivative of this function was this one. You'll be able to work through these steps yourself. It's a matter of doing it term by term, taking a factorisation and realising this is the difference of two squares. That's fairly simple. Then we need to show that that means that there's a maximum and a minimum here and here. So the first thing I need to do is set that equal to 0. So that is at 3. 2 minus x times 2 plus x equals 0. That's the reason that we like it in factorised form, because it makes the solving part easy. The only way that this can equal 0 is if one of these three terms is 0, so we can see that then that means that x equals 2 or minus 2, as was given here and here. Put these 2 points into our little table, and we want to check the n values. Now you can see I've already done a bit of a sketch here of what the negative cubic might look like. Extreme values at this end, coming down this way, and then coming down this way. You can see there's negative gradient and negative gradient. So it means negative, we already know this is flat. We already know this is flat, and then that's negative again. All we need to check is actually a point in the middle here to see if it's positive or negative here. So I'm going to check the point 0, because that's pretty easy to check with. And we'll need to look at the gradient function. So this is our gradient function as we've been shown. But don't forget the original gradient function that we derived right here at the start, 12 minus 3x squared. This is just to show you that sometimes it pays to be really flexible. I could put 0 in here, multiply that out, but if I use this one I can instantly see that when x is 0 I'm left with 12, which is positive. So if you're flexible, it can make some of the calculations easier. As you can see now, I'm coming down, flat spot and then up, makes this one a minimum. This one goes up, flat spot down, makes that a maximum. That's what we had to show, maximum and minimum. Now we're going to try and do a sketch and put all this information together. I need to start by looking at the original function, 12x minus x cubed. I'm going to factorise that. I'm going to take just x out of there. That gives me 12 minus x squared. Now it's not the nicest factorisation, but I can still call this the difference of two squares. It gives me 12 square root of 12. Oh, sorry, that's x square root of 12 minus x, and the square root of 12 plus x. Ultimately, all we're really interested in are these three values, so that we can map them out a little bit on here. So I've got 0, square root of 12. Now the square root of 16 would be 4, the square root of 9 would be 3, so it's somewhere between 3 and 4. And I've got that as a positive value and as a negative value. And then they're my three roots of these cubic. You can see I'm coming down. I'm going to have 3 roots, and off I go. So this is between 3 and 4. Our turning points are at 2 and at minus 2. And in fact we're told that they're minus 2 minus 16 and plus 2 plus 16. We're told that this is a minimum, and we've actually shown that that's a maximum. And then we just need to piece it all together. We can see that that must pass through the root and continue. This one must pass through the root and hit our first turning point. And then in the middle here, 3, 0, and on we go. So we just need to mark on these points, and that is our sketch.